Hello everyone. Today I want to do something a little different. Instead of talking about a programming language framework or any interview question, I want to take a product that millions of us use every day and figure out what's actually happening behind the scenes, and that product is Discord. Now think about this for a second. You open a Discord, okay? You see who's online, you join a server, you send a message, you hop into a voice channel, and somehow everything feels instant. Like there's no refresh button, there's no waiting, everything just works. But behind that simple experience is a surprisingly complex system. So in this video, let's understand what happens behind the scenes of Discord. So let's follow a single message. Okay, from the moment you press enter and see everything happening in the background. Before we even send a message, Discord is already doing work. The moment I open Discord, the app needs to connect to Discord's infrastructure. Now, most websites work like this. You request data and the server responds. Connection closes. Then later you make another request. But imagine Discord work like that. So every second your app would need to ask any new messages, anyone online, any notifications. That would be incredibly inefficient. Instead, Discord does something smarter. It opens a WebSocket connection. Think of it like a phone call. Once the call starts, both sides stay connected. Nobody hangs up after every sentence. Discord works in a very similar way. The app opens a connection and keep it alive. And this is the first reason Discord feels fast, because Discord doesn't wait for you to ask for updates. It can send updates immediately. Now here's something most people never think about. How does Discord know you're online? It's actually surprisingly simple. So every few seconds, your Discord client sends a tiny signal to Discord. It's basically saying, hey, I'm still connected, don't mark me offline. So these tiny signals are called heartbeats. As long as Discord keeps receiving them, your status remains online. But the moment those signals stop arriving, Discord assumes you're disconnected and your status changes. Not because you clicked anything, but because the system stopped hearing from you. Discord even has a dedicated presence service responsible for tracking all of this. Its only job is knowing who's online, and that's an important engineering principle. Large systems split responsibilities. One service, one job. Now let's finally send up a message. Let's say I type, hey, are you free for a call, and press enter. So most beginners imagine the message immediately goes to the database, but that's not what happens. The first thing the message reaches is a gateway server. Think of gateway as Discord's front door. So millions of users are connected to gateways. Their job isn't storing messages, their job isn't sending notifications, their job isn't handling voice channel, their job is managing connections. That's it. So when a message arrives, so when a message arrives, the gateway forwards it to another service responsible for messages, that is message service. Now imagine Discord blindly accepted every message. That would be disaster. Before storing anything, Discord verifies multiple things. Does the user exist? Does the server exist? Does the channel exist? Does the user have permissions to send messages? Is the request valid? These checks happen constantly. And this principle you'll see in almost every backend system. Now here's a really interesting engineering decision. Once the message is validated, Discord stores it before delivering it. And this might sound backwards. Why not send it first and save it later? Imagine Discord sends your message to everyone and then the server crashes. The message appeared but it was never saved. Now message history is broken. To avoid that, Discord saves first, then distributes. This guarantees reliability. The message now exists permanently. You can reopen Discord tomorrow, next week, next month, and that message is still there because it was safely stored before anything else happened. Now the message exists in database, but Discord isn't done. The moment the message is stored, Discord creates something called an event. Think of it like an announcement. Discord is basically saying a new message was created, and now multiple systems can react to that announcement. Notifications can react, search system can react, analytics systems can react, vision systems can react. And none of these services need to know about each other. So this architecture is called event-driven architecture. And it's one of the reasons large systems remain scalable. Now Discord needs to deliver the message, and remember those WebSocket connections we talked about earlier? This is where they become useful. Discord already knows who's connected. It already knows who's currently viewing the channel. So instead of waiting for users to ask for updates, Discord pushes the message immediately. The moment the message is saved, it gets distributed to everyone connected. That's why Discord feels real time. The message doesn't wait for a refresh, it simply appears. Okay, now imagine your friend isn't currently using Discord. Should Discord send a notification? Maybe, maybe not. Discord first needs to make several decisions. Like, was the user mentioned? Is the channel muted? Are notifications enabled? Only after answering these questions does Discord send a push notification. And notice something important. Notifications are completely separate from messaging. If notifications stop working, messages still work. Separation makes systems much more reliable. Now let's talk about something even harder than messaging. Voice communication. Messages can tolerate delay, voice cannot. If a message arrives 200 milliseconds late, nobody notices. If a voice arrives 200 milliseconds late, everyone notices. conversations start feeling unnatural. People interrupt each other, audio overlaps, the experience breaks. That's why Discord uses a dedicated voice infrastructure. When you speak, your audio is sent to voice servers. Those servers distribute the audio to everyone else in the chat. The entire system is optimized for one thing: low latency. Because the goal isn't just moving data, the goal is making the conversation feel natural. Now let's zoom out and look at the full picture. What looked like a simple messaging app is actually multiple systems working together. WebSockets keeps user connected. Presence services track who's online. Gateway services manages connections. Message services process messages. Database stores history. Event systems connect everything together. Notification services deliver alerts. Voice servers power conversations, and all of this happens in just a few seconds every time you use Discord. That's what makes a software engineering fascinating. The simpler a product feels on the surface, the more engineering is usually happening underneath. And Discord is one of the best example of that. Thanks for watching, and if you like to see more videos like this where we break down real products and understand the engineering behind them, let me know. I'll see you in the next one.